Hello students, I made this video to introduce you to experimental design as an alternative that you can consider for your research project. Whether or not you think that this is for you, I encourage you to view at least this one video, and if you think that this is not for you, then you can just skip video 2 and move on with your life. But if you think that this is something that you can do, then go ahead and move on to video 2, and then maybe afterwards, if you still have questions, just let me know. Okay, so let's get started. I want to take you down through what I think are typical undergraduate research questions, right? So 90% of research project basically boils down to this, right? So you measure your IV, which is X, right? Usually to 1 to 7 scale, and then you measure your dV, which is Y, from a 1 to 7 scale, right? So, and this could be multiple items, one item, whatever, and then you find out how much Y is predicted by X using regression or SEM, etc., and that's great, right? So typically, like for example, you measure the effect of satisfaction, right? How satisfied are you with this hotel, sir? 1 to 7, and then how likely will you come back to this hotel? 1 to 7, and then you measure how much his loyalty is predicted by X, right? Or for example, if you have multiple X, convenience, cost perception, K-pop, or you have moderators, whatever. It's basically you measure, scale this, and then scale this, and then you put it into a regression question. That's fine. However, what if your IV, your independent variable, your X, is not something that you can measure, right? So for example, if you want to test whether in a website you have the buy it now button, right? Usually in shopping websites. So whether if you want to see that red button or orange button produces the most click-through or the most purchases in the website, how do you measure the X? You can't measure how red it is from 1 to 7, right? So the answer to this is that you experiment on it. So for example, again, what if the IV, the X, is something that you want to change? Okay, so let's say you want to compare whether a restaurant that has black ambient color versus a restaurant that has red ambient color, how much would what's the difference between those two in driving impulse buying, right? Or if you want to see whether a person has seen a K-pop video, how does it differ from those who haven't seen it, towards Korean brand preference, etc., etc. So in these kind of questions where you cannot measure the X, or in other words, the X is a categorical variable, then you turn to experiments. Okay, so experiments, the fancy definition, is a planned interference in the natural order of events. But what this means basically is that you have you have one thing, you have another thing, and then you change one thing from a circle, from a square, let's say, to a triangle, and then you measure if your change made a difference to the thing that you did not change. Right? I'll give you a very short example. That let's say if you want to see if people prefer brands from China, Malaysia, or Korea, right? Um, okay, so this is a completely valid, legal, you know, doable scenario for an experiment that undergraduates can use. Uh, so you give 30 people one questionnaire, right? And this questionnaire reads: you are walking down the aisles of Aeon and you see a Korean-made LCD plasma from 1500 down to 799. How likely are you to buy it? And then you give another 30 people a different scenario, only this one, instead of Korean-made, this one is Malaysian-made. Everything else stays the same, and then you measure how likely you are to buy it. So, and then you got the score here. Let's say the score here is around here. On the second scenario, the score is around here, then what do? You do t-test, right? You do t-test to compare whether this number is statistically significant from this number, and if it is or if it isn't, you're done. That's your study, that's your RP, right? So scenarios can be really simple, it can also be really complicated, but essentially it all boils down to making a difference at something and then testing to see whether that difference causes a significant output, right? So in undergraduate level, experiment boils down to having a categorical IV, as I've mentioned, an IV that you cannot measure using an interval scale, and the DV, however, will be interval. Okay, so you can make 2 or more scenarios, right, like the one I've just shown you. You give it to different groups, and then you see whether the differences caused by your change will be statistically significant or not. Okay, and that's it. That's experiments. So it's very good when you want to isolate a cause and effect relationship instead of just measuring whether one correlates or not with the other, right? If you have an independent variable that you think might be better if it's not measured and it's changed instead, and if you want to see that whether those different treatments lead to different results. All right, so that's the end of video 1. If this is something that you think is not for you, then good luck with whatever it is you choose to do. If you think that experiments are interesting and you want to find out more, do stay tuned for video 2 in the next link. Alright, see you then.